Have you ever wondered if we can control the weather? Specifically, can we make it rain on demand? It sounds like a question straight out of a science fiction novel, doesn't it? But believe it or not, there's a scientific technique for this, and it's called cloud seeding. Cloud seeding is a fascinating concept. At its core, it's a method to artificially induce or increase precipitation. That's a fancy way of saying it's a way to make it rain or snow. Now, before we go any further, let's take a quick trip back in time to where it all began. The story of cloud seeding starts in the 1940s, in the laboratories of General Electric. A scientist named Vincent Schaefer discovered that introducing substances like dry ice or silver iodide into a cloud could encourage the formation of ice crystals or raindrops. That's right. The idea of making it rain isn't just a metaphor for wealth or success in pop culture. It's a real scientific process. Schaefer's discovery was groundbreaking, and it opened up a world of possibilities. Could we combat drought by creating rain? Could we clear fog from airports to improve visibility? Could we even control the intensity of hurricanes? These were just some of the questions that cloud seeding prompted. But of course, it wasn't as simple as it sounds. There were challenges, uncertainties, and controversies. Some people worried about the environmental impact. Others questioned its effectiveness. And many were simply awestruck by the idea that humans could manipulate something as vast and powerful as the weather. So, as intriguing as it sounds, we actually have a method to potentially control rainfall. But how does it work? Let's delve into that next. And remember, while the science of cloud seeding is complex, it's also a testament to human ingenuity and our unending quest to understand and influence the world around us. So fasten your seatbelts. We're in for a fascinating journey into the clouds. Now, you might be asking yourself, how does this cloud seeding process work? Well, let's dive into the science of it all, but don't worry. We'll keep it simple and fun. Imagine a cloud as a bustling city in the sky. Its residents are tiny water droplets or ice crystals, just hanging around, waiting for something to happen. And cloud seeding is like throwing a huge city-wide party that nobody can resist. To start the party, substances like silver iodide or liquid propane are introduced into the cloud. Think of these substances as the party starters. They are used because their structures are similar to ice crystals, making them perfect to kick things off. Now, these party starters don't just sit around. They get to work, encouraging the growth of ice crystals. This is like sending out party invitations to all the water droplets in the cloud city. The droplets are drawn to the party starters, and they begin to stick together, forming bigger and bigger clusters. As more and more water droplets join in, the party gets so big that the cloud can't contain it anymore. These clusters of water droplets, now too heavy to float around, start to fall towards the ground. And voila, that's rain for you. But what if it's too cold? Well, then we have a snow party instead. The process is the same, but the water droplets freeze before they hit the ground, turning into beautiful snowflakes. So, in essence, cloud seeding is about encouraging clouds to do what they do naturally, but just a bit faster and on a larger scale. It's like giving Mother Nature a little nudge to help along the weather. And there you have it. That's the ins and outs of how cloud seeding works. We've turned a cloud into a party, and the result is rain or snow. It's quite the feat, isn't it? But you might be wondering, so that's the basic science behind cloud seeding. But the real question is, does it really work? Stay tuned as we delve into that next. So, we've learnt about what cloud seeding is and how it supposedly works. Now, let's address the elephant in the room. Does it actually work? Scientists have been scratching their heads over this question for decades. There have been numerous studies and experiments conducted to assess the effectiveness of cloud seeding. But here's the kicker. It's quite a challenge to measure its success. Why, you ask? Well, it's mainly because of our dear friend, the weather. It's unpredictable, capricious, and doesn't like to play by the rules. Take, for instance, the Wyoming Weather Modification Pilot Project, a decade-long study conducted to evaluate the effectiveness of cloud seeding. Despite the meticulous efforts, the results were inconclusive. The reason? It's difficult to establish a concrete cause and effect relationship between cloud seeding and increased rainfall. You see, weather is a complex beast, influenced by a myriad of factors, and isolating the impact of cloud seeding can be as tricky as finding a needle in a haystack. But not all reports are murky. some studies have shown promising results. A study in Australia, following a severe drought, indicated an increase in rainfall by up to 10% due to cloud seeding. Similarly, in the United Arab Emirates, cloud seeding operations reportedly increased rainfall by a significant margin. However, it's important to approach these findings with a pinch of salt. While they are encouraging, they're not definitive proof that cloud seeding always works. More research is needed to conclusively determine its effectiveness, and scientists are continually working on this. So, does cloud seeding work? The answer is, it's complicated. It might work under certain circumstances, but it's not a guaranteed rain-on-demand service. The science behind it is sound, but nature, as always, has the final say. As you can see, it's not straightforward to measure the success of cloud seeding, but this hasn't stopped countries around the world from trying it out. Despite the uncertainties, many countries have adopted cloud seeding methods. But why? Well, the reasons are as varied as the countries themselves. Firstly, many regions look to cloud seeding to combat the devastating effects of drought. Australia is a prime example of this, with large parts of the country often suffering from dry spells. By seeding clouds, they aim to stimulate rainfall and alleviate the harsh conditions. Now let's swing over to China, a country that has implemented cloud seeding on an enormous scale. They're not just battling drought, but also using this technique to enhance their water supply. With a population of over 1 billion people, ensuring everyone has access to water is a monumental task. Cloud seeding offers a potential solution to this issue. But it's not just about water. Some countries, like the United Arab Emirates, have turned to cloud seeding as a way to reduce air pollution. By inducing rainfall, they hope to wash away pollutants and purify the air. This is especially important in urban areas where air pollution can reach harmful levels. Interestingly, cloud seeding has even been used for political reasons. During the Vietnam War, the US used cloud seeding in a bid to flood the Ho Chi Minh Trail and disrupt enemy supply lines. This initiative, known as Operation Popeye, shows us that the uses of cloud seeding can extend far beyond its original purpose. But it's not all roses. Some countries like India have reported mixed results with cloud seeding. While there have been instances of increased rainfall, there are also times when the technique seems to have little to no effect. And then there are the environmental concerns. Critics argue that tampering with natural weather patterns could have unforeseen consequences, damaging ecosystems and potentially worsening the very problems cloud seeding aims to solve. So, cloud seeding is being used worldwide. But is it really a practical solution? That's a question we'll explore in the next scene. Stay tuned. Now that we know cloud seeding is in use around the globe, we need to ask, is it a practical solution? Cloud seeding, like any other scientific endeavor, comes with its own set of practical considerations. Let's take a closer look at these, starting with the cost. The financial implications of cloud seeding can vary widely, depending on several factors. These include the size of the area to be seeded, the type of technology used, and the duration of the seeding process. Some estimates suggest that the cost can range from a few thousand to several $1,000,000. While this may seem like a hefty sum, when compared to the potential benefits such as increased agricultural yield or replenished water sources, the investment may be worthwhile. Next, let's discuss the infrastructure required for cloud seeding. It's not as simple as just releasing some chemicals into the air. The process requires specialized aircraft or ground-based generators, along with trained personnel to operate them. There's also the need for meteorological equipment to monitor weather conditions and analyze the results. So, the infrastructure for cloud seeding can be quite extensive. Now let's talk about potential environmental impacts. There are concerns about the long-term effects of the chemicals used in cloud seeding on both the environment and human health. While studies so far have not found significant harm, more research is needed to fully understand the implications. Weighing the benefits against the potential downsides is a complex task. On one hand, we have the potential for increased rainfall, which can alleviate drought conditions and support agriculture. On the other hand, we have the costs, the extensive infrastructure requirements, and the potential environmental impacts to consider. As we can see, while cloud seeding has potential, It's not without its challenges. But is it a viable solution? Well, that's a question we'll delve into in our next segment. Stay tuned. Finally, let's consider the ultimate question. Is cloud seeding a viable solution to our weather woes? On the surface, it might appear like a silver lining to our cloud of climate challenges. But let's try to understand this better. Cloud seeding, in essence, is a way to manipulate the weather. It's like having a remote control for the clouds where we can make it rain or snow on cue. Sounds amazing, right? But here's where things get a little stormy. You see, weather patterns are incredibly complex and unpredictable. Even the most advanced supercomputers struggle to accurately forecast the weather more than a few days out. So attempting to control something as capricious as the weather is, to put it mildly, a bit of a dice roll. Besides, there's the question of environmental impact. Introducing foreign substances into the atmosphere might have unintended consequences. For instance, could it affect plant and animal life? Or could it alter weather patterns in unforeseen ways? These are questions we don't have definitive answers to yet. Moreover, the science of cloud seeding is still in its infancy. While we've seen some encouraging results, there's a lot we don't know. How effective is it really? Can it be scaled up to influence weather on a larger scale? And perhaps most importantly, can it be done safely and sustainably? To answer these questions, we need more research. We need to conduct rigorous large-scale studies to understand the full potential and limitations of cloud seeding. We need to explore not just the how, but also the should. Should we be meddling with Mother Nature on such a grand scale? So, while cloud seeding holds promise, it's clear that more research is needed to fully understand its potential and limitations. Because when it comes to the weather, it's always better to be safe than sorry.